So let's do this whiteboard. I want to prove the derived equation for ellipse, and let's see if I can work this thing out here. Yeah. Okay. Well, I got some stuff worked here. So what I wanted to get at is that this distance d1 is from here to C, and this point is an x and a comma y, just a generic x comma y. It doesn't look very good, x comma y. That's this point right here where it's hitting on the curve. So the Greeks said, if you have a string that's going d1 and another string d2, and you have a pencil tied in right here, you see, you put a pencil right here, and then you trace out, you start moving along, and the strings are holding you back. So if I take a particular point, let's see right here, right now, this is d1. It's a lot longer because it's going all the way to C, and this is d2. However, the total distance between the two are the same. So if you take your pencil, go back around over to here and put it here, then you have this thing running from here. You have d2 going from here all the way over, right? And then you're going to have d1 that's going to write all the way back to here, see? Now, if you take this d1 and cut it off with scissors and bring it over here, it'll fit right here, perfect. So what happens is that it ends up being the full length, right? So from 0 here is minus a, and from here to here is a, so the total is going to be 2a, see? So now I'm going to add my distance, d1 plus d2, okay? And the distance formula is going to be x here minus this x minus this c point squared. And then y minus 0, which is going to be the y squared. That's the distance equation. And the other one, d2, is going to be from d2, I'm going to have x minus a minus c. See it? X minus a minus c. Let me clean that up a little bit. So it's x, it's going to be minus a minus c. Okay. And that's equal to a fixed distance, 2a. The collections of all those points, the Greeks said, because they didn't have algebra. They didn't have these letters that we're doing in the prayer. That was the Arabs that came up with algebra, Allah Akbar, Allah. All sorts of stuff like that. Anything with AL is probably an Arabic word. And alcohol is another one. Let's go a little further across here. Okay, so now what I'm going to do is I'm going to take this guy here, this term here, and take it to this side. So then I have this thing by itself over here, right, is this term, and then I have this term. But in order to get rid of this square root here, I'm going to square it, see? And then I have to square the other side too, to be fair. So you know that the square root of x squared is the same as, you can rewrite square root as a half power, and then you can raise that to 2. And that ends up being just 2 over 2, see? And that's just going to be x to the 1, which is just x. Right? So that's how you get rid of the square root. So in essence, when I square this and this, I'm just going to get the same thing back out, except without the square root. You see it? So on this other side, I'm going to have to square it. So I multiply 2a times 2a. That's the 4a. Then I got that. I have to multiply this times that, and that times this, and then this times itself. So they're going to be 2a of this middle term, and another 2a is going to give me a minus 4a squared. Now, before I do that, you can see that this term here, right, this y squared, I can strike out with this squared. See it? And by doing that, I got that going. So let's see, actually this doesn't go here at all. There is no y squared, right, because it's subtracted out. So there we have it. Now, over here, you can see it looks kind of ugly, but I'm going to take this guy and work it out. X times x is x squared with a middle term of 2cx and plus c squared, right? But I can see that the c squared now, because I'm going to solve this side over here, see it? So x times x is x squared, and that's going to be minus 2cx and because it's going to be another one here, and then I have to multiply c by itself as c squared, right? This y squared is gone. So what I have left is all of this, and then I have this term here. By the way, I see that this x squared subtracted to x squared. So if I take this guy and add it over to this guy, I'm going to have a minus 4cx is all I have on the one side. And the other side, I'm going to have the 4, right? It's minus 4a squared. And then over here, you can see I can factor out a 4. A 4 can be brought out, and there's a 4 there. So by the time I'm done, I just, I ended up taking out the 4, because you can factor out a 4 here, right? So all I've done is, pulled out the 4 from both sides. So it looks something like over here on the side. So I do have the minus 4, right, cx, but over here I'll pull out a 4, whoops, and that'll leave me an a squared minus an a times x plus c squared plus y squared. Okay, now that 4, and then you can see, and that 4 divides out, right? You can divide both sides by 4. Okay. So, coming back over to here, now, I'm going to take this guy and move it over to this side. Then I'm going to take this guy and move it over to this side. So it's negative now, so over on this side it becomes positive. And then I have this guy, and it comes behind here, so now I have negative here, so it adds to this, right? Again, I want to get rid of this square root here, so I square it here, and then I have to square it here, right, to be fair. Now, when I square this, I'm going to have the a squared right here, see it? And then I'm going to have this get rid of the square root, see? So now I'm back to there. And then on this side, I'm going to have a times a, then I have a squared times this, and this times a squared, and then this times itself. So what I have is, a to the 4th, and then I'm going to have a middle term of 2acx. And then finally, 2 copies of this would be c squared times x squared. Okay. So now, on this side here, I'm going to distribute this x to each term, the a squared I mean. So now I have a squared x squared, and I have 2axcx, and then I have a squared c squared, right? And then I have a squared times the y squared. And I notice that this and this term are the same, so that goes away. So what I have here is, I have ax squared. Now, I'm going to take this term and bring it over here to be next to this x guy. And I'm going to take this ac to be next to the a to the 4. So when I do that, right, this term went out, so I'm going to take this guy and bring it over. So here I have the ax squared, see it? And then minus the guy I brought over, the cx squared, right? And then I still have my ay in the same position, and that's equal to a to the 4th times a squared, because I brought this term over, right? So that becomes minus a squared c squared. So now, this is a different step here. It looks kind of crude, so let me separate this so you don't see it as the same problem. Okay, now all I did is I factor out an a squared, right? Because that would be a to the 4th c squared, right? And so I factored that way, and then I divided by it, by the same term. So you can see that I divided here by the same term. See it? This term is the same as the top term. And of course, that's equal to 1. Then you have to divide, right here, I factored out an x, right? So here an x, what I had left inside is a squared minus c squared, right? And then I have to put it down here, what I brought over here, I put here. You see the a squared, and then this is minus c squared, right? And then I did it here too. So I have a squared, to be fair, times a minus c squared. See? Well, this is 1. And notice here that this term here, in fact, divides out. So that all you have left on this side is going to be an a. Oh, sorry. You won't have that. You will have, right, that's going to divide out. So what you're going to have is going to be, let's say you're going to have just x squared on the top, right, over a squared. And then here you're going to have the a squared is going to divide out, see? So then what you have now is y squared over a minus b squared. That's what's left on that side. All right? So I took this whole term here and I wrote it over here. So that's, now I'm going to I can let whatever I want, b squared equal to a squared minus c squared. And so now I'm going to replace this with b squared. So what I have is x squared minus a squared, and then that's plus y squared, and this is the equation of an ellipse. That is the algebraic equation, and that can be written on a Cartesian, you know. So now we went from the Greeks to the algebra to Descartes, who came up with a coordinate system of x and y. And we have it written so that the equation can be expressed analytically. Okay.